Hello guys and welcome to this one. Um so like a continuation of what we had yesterday from the offline, here we have the online um sample data, right? And what we're going to be looking to do is basically yeah, okay. So it's basically to look at how we are going to return the random value in an optimized version, right? So let's look at our optimized code. So online sampling. So we set out a subset array. So obviously you remember that from yesterday we're talking about sampling where we have something like a packet coming into a network, and we want to make sure that the sample size k, or yeah, basically k being the sample size or the size of the network storage, gives an equal opportunity to every packet that comes in to be within that storage system. So basically that's what we're trying to see with these lines of code. Now let's get into it. So we say we set up the subset of the array, so it's an empty array. So that would be like the storage of the network, and then we go down, we say for I in the range, the length of the packets coming in, right? And then we say if that is the amount of length of packets coming in. So if length of the subset is less than k, so basically we are saying up until k fills up with you know up until the subset fills up with values from the list, let us just append, let's just keep putting in stuff into the storage until it gets filled. Then we then say unless that, else if it's now up to, say maybe we have a storage of maybe 4 of 3 packets, right, of 3 packets within the storage, then we'll now randomly start selecting. So how do we do that? How do we ensure that probability is sustained? We do that by saying what? We do that by saying, okay, the random index is equals to the random in integer. So we pick out, oh, the fourth, we say the fourth data just came in. Like let's say we have a storage site of a subset with limitations of k, of k, and k is equals to 4. So basically a storage of four, maximum of 4, right? And the fifth one comes in. What do? We bring out an array of numbers, 0 of 1 to 5, right? Basically, since we are working with indexing, it will be 0 to 4, right? For the 5 numbers, 0, 1, 2, 3, 4, right? And then what do? We go ahead to find the random number. So let's say the random number falls on 4, right? That means 4 is already within the list. So that's why I said if the random index is less than k, right? uh Subset array, um let's see, it's a subset array, uh so a subset array at that index of, oh, I see it. Emma Binu. Emma Binu. So if it falls on any of the guys that are less than, we want it to simply replace that guy with the guy that is coming in. That is n at the index of I. Hey, Fufu. This is this is all Fufu. I blame it on Fufu. It literally is right there and I couldn't see it. Fufu. Blame it on Fufu. Fufu did this one. I go lie for you. Fufu did this one. So basically that's what we're trying to do. We're trying to basically, yeah. So when we toss it and we find an index and maybe falls within the probability where we have a number that is less than k as what we find within the random int as the random index, right? So basically what we do is that we replace that number with the value of the number coming in, right? So basically what makes it even is the fact that we are checking the length. So even the ones that were passed, that the past ones that were even rejected, that didn't get into the list, also contribute to the probability of the new one coming in, right? Right? And or you could say the new one coming in, or you could say the other way around, the old ones leaving. So basically that's the whole idea. So we say the subset, then we say subset array, then we replace it and then we print the subset. So basically what we've done now is that we then this is going to be O of n, yes, because we go through every line, but we don't need to now randomly pick it out, or to randomly pass out what we need to do. Basically now what we simply do, or pass out random variables till we get it right, or then we select one. Basically what we are just doing is that we are just randomly selecting within a list, or yeah, within a group or a line of numbers. We just do a random selection and then we append. We don't need to like write everything out in a list brute force way, right? Basically what we're doing is that we're just checking probability and then we're stipulating what's entering, not brute force of printing everything and then just selecting one from everything we've printed. So basically that's the trade-off here. So this is just going to be an O of n iteration, because why? Because it's going through, if the list increases, that's the only thing that will cause increase on this algorithm. Nothing else can cause an increase on this algorithm. We are not what's it called, we are not cutting or doing anything. So basically that's it for this one. Muchas gracias. Bye.